Hello friends, here we have taken another problem of rolling motion. Previous problem is also related to rolling motion, in which a simple solid sphere is given. Here a cylinder is given. So in question given that a plank of mass m kg is placed over a cylinder of mass m as shown in the figure. A horizontal force F is applied on the plank. If slipping is not there at any surface, find the linear acceleration. देखिए बोला गया कि slipping is not happening at any places. That means pure rolling is occur at all the places. Pure rolling is occur. Pure rolling is occur. That means we can apply A equals to R alpha and also V equals to omega r. So here there is no requirement of V equals to omega r. So I am writing only A equals to alpha r. Okay. Now when we have to apply a force F Newton on a plank, then plank move what direction? Forward direction. Then this cylinder will also try to move in forward direction. That's why at the contact point, अपन बात करें, let's talk at the contact point. Then this plank is moved forward direction. Then friction is acting on the backward direction on the plank, and same friction is acting on the forward direction on the plank. Let's suppose this one is F1 and this one is F2, and when the cylinder wants to rotate or move in forward direction, then the tendency of this point is move forward direction. So at that point again on a cylinder, friction will act in backward direction. This one is F1, this is F2, and the same amount of friction is acting on the surface is F2. So once again we can make the diagram of separate. So this is our plank and the force F is applied and the friction F1 is acting on the plank, and this is our solid cylinder having mass m and radius r. Here at that point same amount of friction acting in forward direction, and again F2 friction is acting backward direction. Okay, this part is clear. Actually friction, the main purpose of friction is to oppose the relative motion. जहां पे relative motion होगा वहां पे friction try to oppose the relative motion. Okay, so now we can write the equation. Here we have to ask linear acceleration of plank. Linear acceleration of plank, let's suppose we have assumed that A1 and linear acceleration of cylinder is taken as A. Let कर लिया आपने A और A1. Okay, now we have to write the equation. Let's suppose first of all F1 is unknown, F2 is unknown, and A is also unknown. So we have to write at least three equations. So first of all we have to write the motion of plank, equation of motion of plank. So we can write for equation of motion of plank, for equation of motion of plank, we can write from Newton's second law, applied force minus opposing force is equals to ma. Okay, now this A can be written as in the form of simple A. So let's see the concept of rolling, how we can apply. At that point this point move forward direction with acceleration A, and also due to rotatory motion, here the acceleration is also due to rotatory motion is alpha A, sorry alpha r. So now this will becomes alpha r equals to A, and this is A. So this point, the topmost point of cylinder, is moving with A plus alpha r. That is nothing but A1, because the contact point is also moving with presence on cylinder as well as platform. So A1 is equals to alpha r plus A, and due to pure rolling we can write A equals to r alpha. So we can write A1 can be written as 2A. Okay, so this is also a very important relation we have to use in later on. Okay, so here we can put ma1 in the place of m2a. From this equation we can put, so this is our first equation. Now the same force equation we can write on the cylinder. We can write F1 minus F2 equals to ma. This is equation number 2, and we have to write one equation also. So this is the platform performing only translational motion, but the cylinder is performing translational as well as rotational motion. So we can write the torque equation because of their rotatory motion. So we can write the torque equation. This length is radius, so taken as r. Now we can write torque of F1 and torque of F2. In previous problem, I had also explained that. Here I will also explain. So how we can take the torque R cross F. So when we have to perform R cross F, then the direction of torque is inside the plane or inside the board. Same in the case of F2, the direction of torque is going inside the plane or inside the board. So both are in same sense. So we can simply add it. So we can write F1R plus F2R is equals to I alpha. So alpha of solid cylinder can be written as mr square by 2 into alpha. Now alpha for this can be written as alpha a by r. So we can write a by r. This is equation number 3rd. अपन यहाँ से लिख सकते हैं alpha can be written as a by r. Got it? Now cancelling r, we get F1 plus F2 equals to ma by 2. Okay, so this is our third equation. Okay, this is our third equation. Now add second and third equation. We get, after adding second and third equation, we get 2F1. This one is cancelled out, so 2F1 can be written as 3ma by 2. 3ma by 2. And the value of F1 can be written as 3ma by 4. So once we get the value of F1 put here in the equation number 1, so we can write minus 3ma by 4 is equals to 2ma. Now after simplification we get F can be written as after simplification directly we can write 11ma by 4, and by cross multiplication we can write A can be written as 4f upon 11m. See very carefully. Here we have to ask linear acceleration of Planck. So we have to find the linear acceleration of Planck is A1. So we can write A1 can be written as, A1 is nothing but 2a. So 2a can be written as 8f upon 11m. I think you got it. I will repeat once. Here we have to ask actually linear acceleration of Planck, and the mass of Planck is given and the mass of cylinder is given. You have to very careful about this line here. If slipping is not there at any point, any surface, means everywhere is pure rolling is occurring. Okay, so we can first of all apply the condition of pure rolling A equals to R alpha. So we get the alpha equals to A by R. Okay, now at the topmost point, let's suppose this point is P. At the topmost point we can write, if the acceleration of topmost point of cylinder is, let's suppose A1, then the Planck is also moving with acceleration A1, because both are in contact, so their velocity should be same. For pure rolling, we have studied in previous lecture, for pure rolling velocity of contact point must be same. This is the necessary condition for pure rolling. So we can write here, so by this relation we can write A1 equals to 2a, and after writing the equation of motion of Planck, first equation, then second equation from the motion of cylinder, and then the third equation is torque acting on the cylinder. So after simplifying these three equations we get value of A. So value of A is 4f by 11m, and we have to ask the acceleration of Planck, so we can put the value of A1 is 2a and our answer is 8f by 11m. Once we get the value of A1 or A, we can easily find the value of F1 and F2 also. So in question also asked the amount of friction acting at the ground and cylinder and Planck. So we can solve easily in this way. Okay, thank you.